Dear students, so this problem is based on drift velocity and resistivity of the given material. So here in the given problem, if the magnitude of the drift speeds of free electron in copper wire is 7.8 into 10 to the power of minus 4 meter per second. So this is the drift velocity, and what is the electric field inside the conductor? If this is the drift velocity in a given material, that is copper wire, so what is the electric field inside the conductor? So already they have given some data. So that is specific resistance of the copper and number density of the given copper wire. So first of all, here we know the drift velocity formula. The drift velocity is E by m into tau. So this is the drift velocity formula. So from this I am rearranging the terms electric field, because our aim is to find out electric field. So for this I am doing E is equal to, so that is m Vd by E tau. Here tau is the relaxation time. Here we don't know, we don't have the value of relaxation time tau. So that's why I am doing, we know I am converting relaxation time into other formula, that is we know already resistivity formula, the resistivity, because we have the resistivity value. So that is m by, so n e squared tau. So from this you can write tau is equal to, so mass by n e squared rho. So here we don't know the tau value, that is relaxation time. So we can substitute in place of tau m by n e square rho. So I am substituting here, E is equal to m Vd by E into, so here tau m divided by n e square rho I am substituting. So if you rearrange the terms, so I think m get cancelled here, and e square and one e, so these are also cancelled. So after cancelling all that all two terms, so here you will get n e rho Vd. So this is the term. So now I am writing electric field in terms of drift velocity and resistivity and number density, because I have only these three values. So I know the drift velocity, and I know the resistivity, and also I know the number density. So I am writing electric field in known values, so known terms. So here electric field E is equal to, so n value is, I know the n value is 8.4 into 10 to the power of 28, and E means charge of the electron, that is 1.6 into 10 to the power of minus 19, and the density, sorry, resistivity, the resistivity of the copper wire is 1.7 into 10 to the power of minus 8 into drift velocity already given, that is 7.8 into 10 to the power of minus 4. So now the electric field, if you simplify all these things, you will get a 0.181 volts per meter. So this is the electric field inside the conductor.